All right. Yaron Singer, co-founder and CEO of Robust Intelligence, as well as a professor of computer science and applied math at Harvard University. Welcome to the Data Exchange podcast.
Amazing. Thank you for having me, Ben.
So I've been following your company from the beginning. And in fact, I have a funny story. When your company first started, whenever I would ask someone, is this and you guys have pivoted since then, but I would ask someone, so is this whole adversarial ML, model poisoning, model inversion, is this real? Yes, it's real. Look, there's a company called Robust Intelligence, right? So that's my funny story about Robust Intelligence. But now you folks have got have a much more.
I'm staying silent about this because I want to be polite. So I'm not, I'm being polite by not interrupting you. But you go ahead. You go ahead, and I'll stay polite.
So now
I'll come back to this later.
Yeah. I want to come back to this later. So now you folks have a much more holistic perspective around ML, which is actually the name of the company makes a lot more sense, right? So Robust Intelligence, making sure your ML models are safe, ready for deployment, and robust. And you folks break it down into various areas like pre and post production. But so let's start, Yaron, at the model training step, which is basically you folks are doing testing, which kind of is this. There's this whole broad theme now that I'm noticing around injecting software engineering rigor into how we build and deploy ML. So tell us what exactly are you guys doing at this stage around stress testing?
Oh, perfect. Thanks for this question. But so just before I answer this, I would love to come back to this, talking about.
I will too. Yeah.
And I think that I'll convince, hopefully, 40 minutes from now, I'll convince you that that we're that this space is very real. That are very much there's vast interest in this, and also I think that we'll be putting the kind of the more holistic picture together. So, but we'll get back to this. So let's but I think it's a great start to talk about testing. So, I think when we're thinking about software, right, then it's pretty obvious to us that we need before deploying software in the real world. Obviously, we know that we need to test it. We know that we need to run unit tests. We know that we need to run some stress testing. We know that we need to kind of scan our code for. Right. For
this is all well known for non-ML software.
Exactly. Right. And not surprisingly, right. So because for software, we've it's been in solid engineering practice for decades, right. And I think that what's changing is ML has been largely an academic endeavor outside of say a few places I've seen this at Google and Facebook. Maybe for even 10 or more years ago, right, where it's kind of used for very, very specific use cases. But I think when we're thinking about this community wide, it's been an academic endeavor, and now we're seeing companies deploying these models into production and taking this from an academic endeavor to an engineering discipline, and now we need to kind of develop and these new practices, right, for similar to software engineering, and I think that testing is a big part of it.
But so Yaron, the key difference is there's, as far as I can tell, a couple, right? So one, there's two main elements: data and models, and then secondly, pipelines. And pipelines are hard to test, right?
Yes.
Yeah. And so what kind of tooling do you folks bring to the table?
Okay, great question. I think that the TLDR is that what we bring to the table is testing that is very much targeted towards ML models, right? And specifically we don't look at this, there's a software engineering, an ML system, right, is outside of the ML component, right? It is a software system, right? And for traditional software systems, you have very, very good tools, right, to kind of test them, test the pipelines and whatnot, right? What is different about, about deploying ML is the ML component of it, right? And that's the fact that like now we have a statistical model, right? A statistical entity that lives inside, right, inside our pipeline, right? With all the, all the intricacies, right, with that, right? So for us, what we focus on is what we call silent errors, right? And what that means is it means that we focus on the part where, data point comes in, to the model, right? And a prediction comes out of the model, right? Now, when you're testing this from a purely software perspective, right, the system is fine, right? Input is coming in, output is coming out, it's all good. What we do is we focus on testing in these sort of cases, right, where input is coming in, output is coming out, but the output is wrong, the prediction is wrong, right? And now, what is the definition of wrong? What is the definition of of an erroneous output? So that's the part of testing that we do. We test them, we test models and data, right, to ensure that predictions coming out are correct.
But it's not, so you're not testing for accuracy necessarily, right? So you're testing for I guess unintended consequences or behavior.
Yes, we're looking for basically bad data that can fool models, and the way that we define fooling models is by we test the effect, right, that a data point that a quote unquote bad data point can have on a model, right?
So do you so does that mean then you come up with like you have tools for creating synthetic data for testing?
We do that as well. Yeah, we do that as well. And you're alluding like earlier on to like adversarial attacks and whatnot, and that's very much part of the tool house and part of the things that we test for, right? So it's like one of the things you want to be testing for is you want to test for one of the things you can test has my data been manipulated, right? But you can also test like how robust is my model to various perturbations, realistic perturbations that can come in in the data. Some of it can be due to adversaries, some of it can be due to kind of drift in in various features. Some of it can be because the underlying data is changing. All these sort of like various reasons, right, that can lead to models failing, right?
So different teams have different I guess checklists for when they decide we're ready to deploy, right? So some may want to check for aspects of responsible AI, fairness, and so on and so forth. So do you provide like different kind of templates for people?
That's exactly right. And then I think that you're hitting on and that's exactly the point. So I think like if we take a step back, right, and we think about our goal in the company is what we call this like machine learning integrity, right? Making sure that like the models that we're deploying in production, right, are producing the outputs that we expect them to do this, right? And now one can ask like, well, how does one do this, right? We recognize largely kind of like three critical stages, right, in the model development pipeline. The first one is pre-deployment, right? You finish training your model, right? Now you're about to like ship your model into production. This is like kind of one key point. The second point is while the model is actually in production, right? And at that point, what we would like is we'd like to basically automatically create something to wrap the model around, right? So that in real time, right, you can flag, block, in some cases impute, data points that can lead to erroneous predictions. And the last point is, post-production, right? When we can look at like aggregated results over time, right? Monitor the model and do this through continuous testing, right? So basically these are the kind of like the three critical, the three stages that we recognize as critical, right? In kind of like the deployment pipeline. And those are the points where, if we kind of like deploy testing, right, in these three stages, right, we'll be able to dramatically reduce errors coming from models. And now going back to like what are these errors, right? So now from an engineering perspective, right, the model is agnostic to the origins for why it's making a mistake, right? The origin being like is it an adversary?
Or so Yaron, just to clarify, so is it just a mistake, or do you also test for inadequacy? So fairness, for example, right? So it's not a mistake. It's just that maybe it's not adequate.
Exactly. Like from an engineering, like it has like a very, very different societal context, but like, right, from an engineering perspective, right, fair, like kind of a bias, right, is model error, right? And that model error comes from the fact that, well, we've actually, it can come from various reasons, but basically, well, one thing is like, we trained a model on, on this data set, and now we're deploying on that data set. Or, we deployed a model like to production without testing it and realizing that it has like really poor performance on some populations, right? Which happens a lot. You have like really high AUC, right? But then you have like a population that is underrepresented, right? Where the model is performing really poorly on, right? And now like, you kind of, you still have like high like traditional performance, because that population is represents a small sample, right? But it can be really affected by the mistakes that the model is making. So all these, like, again, the societal context of it, right, are very different from, like drift or an adversarial attack, right? But from a technical perspective, it's really kind of solving for the same problem.
So who is meant to use at least on the software, on the testing phase? So who is the intended user? Is it so are you seeing, Yaron, ML teams kind of similar to software development teams? They might have people whose job is to test the software. So are there people specifically tasked with testing the model?
Yeah, I think that's a great question. I think being realistic, right? I think that it's still a little bit early, right? For there to be kind of like, for us to like,
pen testers for models.
Well, exactly, like QA testing. But look, I mean,
Yes.
I can tell you that Microsoft has a red team, and we hired some people from, some amazing people from that team, from AI.
Because it's a different mindset, right?
It's a different mindset. You're looking for, it's it's kind of like also in academia, you see kind of people who are like, there's some people who like, it's like looking at the negatives. Like some people develop algorithms by trying to come up with impossibility results for these algorithms, and that's how they, I had an amazing grad student that's exactly what was his technique. But you're basically kind of like, you're thinking in a very negative way. You're thinking about like, what are all the bad things that can happen to, to these models that can actually occur in reality.
And there's a certain degree of relentlessness.
There's a certain degree of relentlessness. But I think, like, going back to the question of like, are there QA teams or red team or kind of like red teams in organizations right now? No, like, and it's because, again, as an engineering discipline, this is a little bit, we're a little bit early,
but maybe if a tool like Robust,
absolutely.
Let's say I build my own model,
exactly,
but I have access to robust intelligence, so it's in many ways it's testing it for me instead.
That's exactly right. I think that's exactly right. So that's where, like, philosophically as a company, we sort of think of ourselves not only as a company that's building a product, but like, how can we be for these organizations, right? How can we be the ML integrity, right, team, at that organization? How can we how can we fulfill that role, right, through a product, right? And that's exactly what the product does. So so really what it does is like it seamlessly integrates like with the existing workflows that that the organizations have, so that testing is done in the background, in real time, post deployment, right? So that there's no additional strenuous for an organization to to kind of run.
So wait, what about pre-deployment?
Yeah, pre-deployment
in the staging environment, right? So let me so one of the trends in testing obviously is automation.
Yes. So
I'm assuming you're using AI to test AI, right?
That's exactly right. We're using AI to test AI, and automation is a big part of the philosophy here. Yes.
So how do you? So I guess this is a podcast, so you can't show me the UX. But so I have a model. So let's say I've trained the model. So you guys start when I've trained the model, right?
Yeah. Yes.
So I've trained the model. So what exactly do I feed into the system? Is it the model, the training data?
Great question. So yeah, you can at minimum, at minimum we would need production data, right? Or or whatever data that you actually want to test. Better yet is training data plus production data. Better yet, training data plus production data plus
And the model you don't care what the model is. It could be
we don't care
XGBoost, it could be computer vision, it could be NLP, right? So
exactly. Generally, at a very high level, generally speaking, a model is a black box, right? Where it takes, knows how to take a data point, knows how to return, prediction, generally speaking, right? And as long as the model responds, respects that, those conditions, that's a model. Now it can be, it can be, XGBoost, it can be like a deep learning model, large, it can be really kind of, a nearest neighbor, right? We had that as well.
So, but what are some of the knobs do I turn? Like, can I say, I want to generate synthetic data for some edge cases, or so?
Yeah,
what are some of the knobs?
Good. So, well, okay. So first of all, like everything's configurable, right? To the point where you can like not only create your own customized metrics and things that you want to follow, but you can also create your own customized tests, right? And in the tests that we have, they're based off of, every test like either has thresholds of, does it pass, does it not pass? And if it doesn't pass, then what are, the levels of severity? So you can, and you can tune these knobs, right, to sort of decide on what is your threshold for test passing, not passing, and whatnot. We do this automatically in the product so that it is a seamless process, right? And one of the nice things is like, for example, you don't have to, tell the product like, okay, this is a categorical feature, this is a numerical feature, this is this, this is that. It automatically kind of understands that and configures that on its own. This is important because the organizations that we typically work with, they're at the tens and now like hundreds and thousands of models, right? And when you're thinking about this, if you're now the VP of data science, head of ML, right, of that kind of organization, right, and now you're asking yourself, okay, we have hundreds of models, right? Obviously, I need to test them before they go into production. I need to like protect them somehow while they're in production, and I want to kind of like monitor them and test them post-production, right? But now I have like hundreds of thousands of these, right? Am I really gonna like now have every data scientist create, like start playing with a dashboard and kind of create a tune, like what are the threats? That just doesn't scale, right? So automation is a huge component of this, where what you want is a product that you can trust, right? That can automatically, run these tests for these thousands of models, right? Automatically configure, all the thresholds based off of the response of, of the model to like, various, underlying, issues and mistakes, right? And can automatically monitor this and kind of like give you intelligent decisions. And what you also don't want is you don't want to have like this kind of like alert fatigue, right? Where every time that something, drops a little bit or not, or like there's a feature that's like responding or not responding, or something has been cut, right? Then now is like, you're getting all these alerts that, that don't.
Right. That leads to the ops team not paying attention to your dashboard.
But that's exactly
right. So let me ask you this. So post deployment, you said you have tools for monitoring.
Yeah.
Right. So as you know, there's startups that only offer monitoring, right? So yeah. So talk to me about your monitoring tools in terms of are they meant to be replacement for some of these other tools, or?
I think, yeah. So, so we've been viewing these, and honestly, there are a lot of really, like, first of all.
By the way, I'm not a big fan of the point solution, just so you know.
No. Like, listen, when generally, taking a step back, when you look at this MLOps community and the companies coming out of this, honestly, they're just like, seriously, just like amazing companies, right? Hyper brilliant people, right? And the products are, fascinating products, right? I think that we've been like our our approach has been, like I think kind of vastly different. Right? So, we've first of all, like we like you're mentioning that before doing this, I was as professor at Harvard, and so these have been things that we've been kind of like thinking about for quite some time, and about model robustness and what is the right framework and whatnot, right? So I think that like when you're thinking about like kind of creating a dashboard, that's something that's like pretty natural for like for data scientists to do once kind of like they graduate from a notebook, right? So a lot of times and we've seen this like kind of like this adoption of a business analytics approach, right? So what do we do in kind of like a business analytics? Okay, like we can it's like it's very easy to create like a dashboard, right? We have like all these great open source tools that allow us to do this. You can use like kind of Grafana and Prometheus databases. They're really fantastic. And then they kind of like, the next thing after you have like a model, you create it in a notebook, probably the next thing you'll do, can do after that is you can see kind of like, you can see what your model is doing, like by kind of like hooking it up to a dashboard. And I think that makes sense at the individual data scientist level. And then if you're a team of one or a couple of people, I think that makes sense. When you're thinking about this organizationally, then it becomes a little bit more challenging, right? Because now you have to coordinate, amongst,
well, you've got all sorts of model governance issues, right? So, but then also now you're in the territory of ops, and for me, ops has a few key components, right? So there's monitoring, there's root cause analysis, and then basically the end goal is to make sure your mean time to recovery is as slow as possible.
Exactly. So I think that we're big believers in the testing driven approach, right? Which is kind of like what we do in software engineering, cybersecurity, right? And this is why we kind of you deploy the tests before the models go into production. You basically create what we call like an AI firewall that wraps around the models in real time.
But how do you help me? Do you help me diagnose? Because in ML, many times, not all the time, but many times when a model starts degrading or underperforming, it's usually some freaking pipeline upstream.
Yeah, exactly.
So do you help me all the way to like tracing what's going on?
Yes, and that like we don't at this moment we don't connect to like any pipeline like kind of
well, can you tell me like maybe it's because of this feature?
Yes,
this feature is being miscomputed, right? So
that's exactly right, and then you get that through testing, right? Okay. If you're now doing rigorous testing, and now like let's say prediction drops, right? So now you can immediately the product immediately kind of attributes to like why is prediction dropping, right? Correlates it with the tests that are failing, right? And now it's telling you exactly not only that this feature is the issue, but it's telling you exactly what is the issue with that feature. And that's this is where we see kind of companies. I can't tell you like how many conversations we've had where a company comes in, they're like, we're looking for a monitoring solution. We're like, okay, well here's what and this is the first testing solution that they I think the only testing solution that they've seen, and done. That's it. I think once you see that, right, then it's pretty convincing.
So most teams, so for example, when you enter into conversations with teams, right? So these are teams that you're thinking of becoming users of your product. What are they using today?
That's a question that we're asking them.
It's all ad hoc, right?
Yes.
Yeah.
Yes, and then that's kind of where, and that's why I'm honestly, well, I guess this is a podcast, so we shouldn't say this. We're just surprised that we're the only testing solution out there, because like the need is massive.
Right. And so
but don't if you're listening and then thinking about starting a company, don't enter this space. Yeah. It's full of thorns. Don't try it at home.
Feel free to decline answering this question, but right now,
I feel like I'm going to decline it. But
so right now, of your users, so give us a typical profile. Are they mainly in computer vision? Are they mainly using deep learning? Are they in finance or healthcare? Just high level.
Yeah, that's been really interesting. So we've well, I don't know if you know, we have like a pretty substantial like enterprises that are heavy customers of the company. And for us, it's been, it's been educational to sort of see companies across the board, from kind of the very largest like financial institutions, like to insurance companies, to like large e-commerce companies, to like companies in the medical devices space, bioinformatics space.
So these are companies using a combination of open source, non-open source, right? So TensorFlow, SAS.
Yeah, so we see, so some of them are, the reality of it, the reality is that the majority of the companies that are mature enough are primarily they're tabular, right? But we also have customers. We also have like customers in vision, and NLP is a huge use case as well for like large, very large scale NLP models, open source models. That's a huge issue now as well, as you can imagine.
So is that so testing there, is it because of the chatbot conversational AI application? So what is why do I need to test so rigorously my NLP model?
Yeah, I mean, like, gosh, like, do you have an hour? Like, how long do we have? But okay, very, very briefly, like, let's start from, number one. Generally speaking, like, like as we said, it's hard to imagine deploying any piece of software, let alone like these models, without testing. Period. But now, when we're talking about NLP specifically, I think that we understand that the risk is larger, because it's very difficult. It's very rare that we see organizations that are developing, their own NLP models now from scratch, right? So usually you inherit some kind of, you inherit it through open source and
pre-trained model. By the way, I was just I had a Twitter space this morning, and we were talking about this whole area. I said, it's not just the pre-trained models that concern me, honestly. It's even the entire Python ecosystem, because anytime you pip install something, there's so many dependencies. The dependency graph of that one library is insane.
You're absolutely right. And you were talking about this space earlier. If you want, like, after we close this video, I'll show you a demo that will knock your socks off for the kind of things that you can do, right? The kind of vulnerabilities that you're exposed to when you're using open source models, when you're pip installing these models now.
So here's a question for you. So what distinguishes the profile? So obviously you alluded to number of models, right? So what distinguishes the profile of a company that's really eager to work with you now, voluntarily, as opposed to people you still have to convince? Is it because they're in a regulated industry as opposed to not? So is there a shortcut for you?
First of all, everybody's eager to work with me individually, specifically. I don't know about others, but like when it comes to me and you have the opportunity to work with me, you're like, oh, of course then. But outside of that, I think that it's definitely, first of all, I think that you're absolutely right. There are drivers that where you have like of urgency, and regulation is a big part of it. We actually have a few big partnerships on regulation testing, because like there's a lot of like very, very like hard requirements now for like regulating AI. The EU, there's in New York, there's like for HR companies that are operating in New York, they need to have like some testing for biases, and in everywhere, like regulated industries, right? So we have like a few very, very large.
So Yaron, do you have to like develop some sort of test suite so that you can tell the company, look, if you use this, you're in compliance with this rules.
Yes, exactly. So we have test suites exactly like devoted to compliance, for FDA compliance and SR 11.7 compliance, EEOC compliance regulation.
I should introduce you to a law firm I advise. They're the first law firm focused on AI.
It is.
P&H.
I know. Yes, I know.
I'm an advisor.
Yeah, I was fortunate enough to like meet them on we were doing a panel, a panel together, and very super bright
Yeah,
people.
there are a lot of chief legal counsels are really concerned about these issues.
Yep. Yeah. No, they're you know, I think it's a very interesting space, and you know, and yeah, and there's a lot of, you know, there's big urgency there. I think that, you know, there's I think that, but basically, you know, like, but going back to like what is a good customer versus what is the ideal customer versus like a less ideal customer for, you know, for the company, is like, look, I mean, like at the end of the day, this is very, you know, this is infrastructure, right? So I think that you know, what we see that there is a you know, there's just like kind of an issue of maturity, like, you know, how mature are you in your journey towards deploying, you know, AI models, and once you hit that level of maturity that, you know, your models are not deployed, then I think you're in need of.
Or also yeah, you're right. So in the beginning you go, okay, if I can just deploy logistic regression, you know, I'm good. It's better than nothing, right? So then your need and your sophistication grows, and then you want more protection in terms of.
I think that once your model goes into production, and you know, they're actually kind of, you know, it's a, you know, you care enough about this model so that if it makes mistakes, then you're bothered by it. It doesn't matter if it's linear regression, you know, or whatever, but like, if, you know, like if you're somehow, you know, your business somehow, like, you know, depends on this, then yeah, this is something that's critical for you.
So who is driving interest in robust intelligence type solutions within a company? Is it the data and ML teams, or is it the platform infrastructure people, or is it the compliance people?
Yeah, that's a great question. So I think that, like, for us, like, typically the interest comes from the data science teams, like, you know, normally at the level of, you know, a VP of data science that is kind of like recognizes that this is something that
very enlightened VP of data science, right?
Yeah,
because a lot of them just want to move fast and deploy, right? So,
but even absolutely, but even when you want to move fast and deploy, right? Like if it takes you like 6 months to deploy your models because, like, you know, you're just constantly, you know, like all your resources go on and then trying to test this and like and firefight these models, then you know, even if you just want to deploy quickly, then, you know, having something that automatically kind of tests your models before deployment, like, will accelerate that process as well. So yeah, so I think, but yeah, so I think that's sort of like the main. I think that's where it's coming from. But then, but yeah, then we work closely with compliance teams. We work closely, obviously, with the, you know, the platform teams, you know, IT and whatnot, to, like, you know, make sure that this is deployed, you know, with compliance teams, making sure that, you know, they have everything that they need to be, you know, kind of compliant with regulation and whatnot.
So you offered earlier to convince me that model inversion and model extraction, model poisoning, maybe, yeah, model inversion and extraction. Whenever I read the paper, it seems like it's not a real world example. You know, the reason, so what I'm alluding to, Yaron, is when you think about cybersecurity and data attacks, there's so many headlines, they're real. Right. But this model inversion, model extraction, it's mostly the researchers who talk about it. But then give me a couple, 2 or 3 examples in the real world. I don't think anyone can do that, right?
No, I mean, so first of all, like, you should interview, like, for this, you should interview. We have Hiram Anderson in the company who's done this at Microsoft, and he was leading this effort at Microsoft, and he joined the company. He joined Robust Intelligence, and he's.
Oh, but have you seen a headline? Hackers extracted the model from.
Yes. So you know, there are quite a few stories. Well, first of all, like, you know, they're the famous ones. Whenever, you know, we're like, didn't Facebook, or sorry, Meta, just last week, like, deploy the chatbot, and, you know, and people were asking about.
Yeah, but that's not that's basically they attacked and became misbehaved. Right. They didn't reverse engineer the model.
Right, but I mean, like, I mean, it kind of is, like we've seen this in 2016 when Microsoft, like, like
Oh no, no, yeah,
the
this
chatbot,
part where you
right,
can
where
kind
people
of
like figured out that it was taking like, it's data, it's
yeah.
training data, like from Twitter, and then like they immediately kind of like poisoned Twitter,
I completely buy that you can
right? So we've seen that,
poison the model, get it to misbehave.
yeah,
But the people who talk about model inversion and model extraction, what's the example?
So we've seen people that have there was a case where I think OpenAI, I believe it was a couple of years ago. Like I think they released like one of their GPT, not GPT-3, but I think like one of these models, and then somebody basically kind of like queried that model and reverse engineered
Okay.
the model. So somehow like basically kind of stealing very valuable IP there, right? So we've seen this, and and look, I mean like there are a lot of things that you don't hear about.
But it's not like data security, right? So data security is real, right? So, in fact, cyber security is essentially data security because all they do is break in and then grab data.
I think that like let's I think if I mean we can have this discussion. We can also have this discussion offline, and I can give you offline. I can also give you a lot of like interesting examples, very real examples that you very much put in the that would make you like very much that have that this flavor of like hardcore cybersecurity flavor on AI models, right? But I think that's a less interesting conversation. If you kind of like take a step back and you sort of think about this now, think about this holistically, right? And if you think about this, once with software, once we basically connected to the internet, right? That's when cybersecurity became a thing, right? And there's no kind of like one solution with cybersecurity, right? And that like okay, it's just like now we need like an entire right now right like now we need there's we're so exposed, right?
It's a very confusing space for those of us on the outside because every now and then I actually go attend cybersecurity conferences just to walk around the expo hall.
Yes,
and it's everyone is using the same buzzwords.
No, listen, it's very confusing, but like but we can't but we cannot like but we're but when we're thinking about this, right, like functionally we have the software engineering, right? But then one again, like as we're now that we've deployed this like to the internet, right, it's exposed, then there's basically an entire ecosystem, right, of of products and best practices and an entire discipline on how to protect, right, these like
so now they all claim they're using AI.
They're all claiming that they're using AI. But now if we're thinking about AI and machine learning, if we kind of like think about that as the analog, right, then now we're basically fighting a conceptually similar, right, but mechanically and technically like different set of challenges, right? Where now it's like we're entrusted with with now kind of like protecting these ML models and kind of like making sure that they act accordingly. And this is kind of what we call ML integrity, right? And now what you need is like again an entire ecosystem, right, of of tools, right, that can be used to like specifically protect this kind of software, right, these kinds of models, right, to ensure that they act appropriately, that they act correctly, right? So I think that's kind of
well the whole don't you think the whole umbrella term responsible AI collects a lot of these risks? So you have fairness, safety and reliability, privacy and security, right, transparency. So each of those areas has tools, right? So security and privacy, you have these tools around confidential computing, right? So secure multi-party computation, homomorphic encryption, differential privacy, so on and so forth. So each area has its own tools, but then at some point, as you point out, maybe someone has to kind of have a much more holistic.
Right, but and that's exactly right. And this is where right, like all the things that we just mentioned, right? They're they're general kind of like they're very powerful tools, right, for computing in general.
But they're all specialized and kind of siloed, right?
Yes, but and they also like and none of them are ML specific, right?
Right.
I think that like when we're developing ML models, right, we want to have kind of like a very clear perspective on what is it that we need to do, right, in order to protect ML models specifically, right? Not have like generic, solutions for, like data, we need to have solutions for data privacy, anyway, and that's something that needs to be taken care of separately, right? But when we're, when we're thinking about machine learning engineers, data scientists, right, and now like they're interested with, integrity of their models, right? So what is it that that we can create, right, to ensure the integrity of these models, ensuring that like data points coming in, predictions are coming out, right, and these predictions are correct, right? That's kind of the thing that we can focus on.
So there must be a lot of things you can learn from traditional software because as you point out, you treat the model as a black box.
Yes.
Traditional software will treat the web service as just a web service.
Exactly.
Then you've got input, output, SQL injection, and so on and so forth, right? So,
exactly. I think that's exactly right. So conceptually, we very much try to make these analogies, right? Then, the devil's in the details, right? And specifically the fact that we're like, that we are dealing with, that this black box, right, is hypersensitive, right, to like these very, very small.
And I guess, Yaron, also ML is inherently stochastic, right?
That's exactly right. That's exactly right.
Yeah.
And exactly, it's inherently stochastic, right? It's a statistical entity, right? The types of changes that we see in, like in the underlying data, right? They're unique to ML. And then everything, and then we also need to like, and also we have like ML gives us like basically some sort of ground truth. Specifically, right? We can, we're talking about monitoring earlier, right? And we're talking about alert fatigue, right? Like every day, like models collect like, thousands of features, right? And thousands of engineered features. And, like all the time they break, right? And something goes wrong, they, some sort of data source pauses and changes and whatnot, right? But the question is like, does it matter, right? And, it could be that like maybe a model, has been trained to like ignore some features, right? Or even if it takes some features, right, it doesn't put a lot, doesn't attribute like a lot of value on them, right? So it's like the model, itself, right, is a very good indication for, when an error actually, produces something that you actually care about, and that's how something that's really important. So when we're going back to like asking, like looking at models, being different from from software, it's like the models also give us this indication, right, of what sort of like errors we should be paying attention to. And those are the errors that affect the model predictions. So
a year or two from now, where are we in terms of testing ML? Is it going to be a hard requirement at that point? I guess it never will be, but probably more commonplace, right? So,
I mean, it's definitely like, yes, the answer is yes. Hard requirement, yes. I mean, and we're already seeing hard requirements like with regulation. If you look at, if you open the, these documents about, like existing like regulation on AI, right? And you're asking, like looking like, what does it require? Like the New York City hiring law, right? AI hiring law, right? What does it require? Testing of models, right? If you look at like EU regulation, what does it require? Testing of models, right? So like, I think, it's being written into the law as, as we speak. Right. And I think that as an engineering paradigm, it's being kind of, now the kind of like the accepted engineering paradigm. And we're seeing kind of like all these leading organizations. We're actually having, we're doing a conference on ML integrity with all these, leading like business organizations, like, chief data officers at all these like amazing organizations like ADP and MasterCard and PayPal and all these places. And that's kind of, that's the standard now. The standard is, testing these models before they go into production, during production, post-production. There's no other way.
One vertical which I would imagine is further along, and you tell me if I'm wrong, is industrial AI, because maybe they're more used to testing, right? So in factories or transportation, in places like, I mean, transportation itself has its own regulator, right? So, but also they're much more pragmatic than the typical web company, because they have to take safety much more seriously, right? So if they have to use domain knowledge, some rules or some control theory, they're not purists, right? So whereas sometimes I think the ML community is, we got to learn everything from scratch, right? So
yeah. We have some engagements with like with large manufacturing companies, and we see the seriousness in which they take testing, right?
yeah, life and death situation, right? So
yeah, and then we also have with semiconductor companies and chip manufacturing companies. They're very, very serious about it. It's admirable, and I think that's the standard that we'll pretty much see all the industry following. Yeah.
So one last thing. So I don't know how familiar you are with this, which is basically in the language space.
Yeah.
Right. So as we alluded to, the deploying language models, you have to be careful. And I think organizations like OpenAI and others are starting to kind of put in detoxification tests and controls for their models, but it's very early on. Very, very early on. But I think maybe companies like yourself can make this kinds of things much more possible for regular teams, not the most advanced teams like OpenAI and Google, right? So,
yeah, exactly. And I think it's look, I mean, I think it's I'm so happy that they're doing this, and I think it's really important because a lot of there are a lot of consumers for these models, right? And I think that they also the industry is also looking at at what they do as as best practices. So I think it is really, really important that they continue on doing this. And you're right that like not, I think very few. It's hard for me to even it's hard for me to enumerate companies that can actually afford to build kind of these kinds of practices in house. Like I've been humbled, when we started the company, you sort of initially kind of think, oh, we'll just do some testing, kind of we'll write some code but then as 50 people later, right, or 60 people later, I don't know, right, you're humbled by the experience, and you realize it's just like a massive engineering effort in order to do this properly.
Yeah, and the goal here is to free up time for companies so they can focus on their core business rather than on writing all these tests, right?
Yeah. Neil, so I think Jeff Bezos was once quoted, and I think Mark Andreessen said it before him, but basically they were saying when they were introducing I think AWS, they gave this example where I think in the 19th century, as kind of like electricity was started to be being used, you had all these breweries in Germany who initially, some of them produced their own electricity, right? And then when you look at I don't know, 100 150 years later, that when you look at the breweries that have succeeded and survived, they're actually the ones who did not produce their own electricity, because they realized that producing electricity doesn't make your beer taste better. Right. So I think it's kind of organizations, typically the successful organizations, they focus on the things that they have a competitive advantage at, and the things that they want to do better. And outside of robust intelligence, not a lot of companies, their goal is to do AI testing better, right? So if and that's where we see kind of a lot of companies being very happy to outsource this to to robust intelligence.
And with that, thank you, Yaron Singer.
Okay, thanks, Ben.